Good afternoon or good evening, class. I'm hoping everyone is doing well and staying safe out there in light of the COVID-19 pandemic. I want to begin by saying that I think it's a surprise to all of us that our semester was interrupted in this way. Virtual classes are pretty fun and can be very effective. However, the nature of our course content in our class makes this a little more challenging. But I want you guys to know that on my end, at least, I'm going to do everything that I can to ensure that I am delivering the information to you effectively, and that you are able to complete all of your assessments successfully and ultimately do well in the course. Okay, with that said, I do want to let you know that because of the circumstances, I am going to be using maximum levels of flexibility in this course when it comes to assignments and quizzes and whatnot. I realize that this is very difficult stuff to learn, and doing this online makes it a bit more challenging. So I will be working with you to ensure that the semester goes as well as possible. Okay. Now, I did upload an updated version of the syllabus. It is on Blackboard now. Okay, so I just want to really quickly show you the changes that have been made. Everything up on these pages is basically the same. The changes are reflected in the course schedule. Okay, so you can see that it reflects the first week of spring break and then the extended spring break. So we are starting here at week 10. Okay, now from here on out, I don't want you to focus too much on these chapter text outlines for the dates. Okay, don't focus too much on that. What we are going to be doing is we are going to be covering lessons based on the week. Okay, so this week we are overviewing week 10 lessons. So anything that is posted on Blackboard that says week 10, you know that that's stuff related to this week. Okay. I also have indicated pop quizzes and when they're going to take place. So your remaining pop quizzes can be seen here in the red text. Okay. Now these pop quizzes are already on Blackboard, and I have them set to open up on the designated days. Okay. So make sure that you look at the syllabus and you put these dates into your calendar to remind yourself to take those quizzes. Now, all of the quizzes are set to open at 8 o'clock in the morning on those days, and they close right before midnight at 11:59. Okay. You don't have an unlimited time to take the quiz. Okay. I do have a window, so you have 20 minutes to take the quizzes, but the quizzes are available to you most of the day. Okay. So make sure that you put this in your calendar and that you get those done. Assignments will be relayed and turned in the same manner that they have been over the past semester. So you just upload your documents to Blackboard for me to grade. Okay. All right. Now for this week, before I move on to that, I do want to say that the university is not allowing faculty to meet face-to-face with students. Okay. So office hours are going to work a little differently from here on out. If you have any questions on, related to the class or your performance or the homework assignments, your best bet is to email me, and I will probably set up a phone call with you. Okay, so we'll talk over the phone, or we can do some type of video chat thing, but I am not allowed to meet anyone in person for the remainder of the semester. Okay, so just keep that in mind. If ever you do need anything, I'm just an email away. Okay. All right. So on Blackboard, I've uploaded a document for week 10. Okay, it is this PDF here that covers correlations. Okay, so this week we are covering bivariate associations. Okay, bivariate associations is just a term that is referring to the relationships between two variables. Okay, correlations are a method by which we can look at the relationship between two types of variables, and particularly we are looking at continuous types of variables. Okay, so remember that for correlations can only be used to look at the relationship between two continuous level variables, okay? Now, when we run a correlation of two variables, we're looking at how those variables relate to one another, okay? What is the relationship? When we run a correlation, we use a value called the Pearson's correlation coefficient, okay? This coefficient is a number that tells us two things. It tells us the direction of the relationship, and then it tells us about the strength of the relationship. And we'll talk about this in this following part of the handout below, okay? So here's a very quick example of running a correlation between two continuous type variables, okay? One of the classic examples that we use is the relationship between height and weight, okay? Because the idea is that as a person gets taller, they should weigh more, okay? And that is typically what we see, okay? So this scatter plot here, a scatter plot is sort of a visual of when you're plotting a correlation between two types of variables, okay? So this is a scatter plot. We can see the height variable here, and then we can see the weight variable here, okay? All of these individual dots are individual level data on a respondent. So each of these is reflecting a respondent's height and weight, okay? Now, the classic relationship between height and weight is as height increases, right, your weight increases, okay? And we can see that portrayed in the scatter plot, okay? Because as your height goes up, as it goes this way, your weight also increases. We know this because if we were to draw a line through these dots here, it's kind of going this way, okay? Any line that's going this way means that as this value is increasing, this value is increasing too. So the line's going this way, okay? So we would actually call this a positive correlation, okay? And I'll go into a little more detail in just a second, okay? Now, when we plot a correlation like this, we're not necessarily saying, okay, this is a perfect relationship between height and weight, because frankly, it's not. It's not a perfect relationship. You will run into instances where you see a short person who weighs more than a tall person, okay? So those are instances where height and weight are not positively associated, okay? But for the most part, what we know based on this correlation is that the general tendency is that height and weight increase together. As one goes up, the other goes up, okay? Now, once we run a correlation, especially when we're doing this on SPSS, okay, it's going to generate a correlation coefficient, okay, which is represented by the letter R, okay? In this case, the correlation coefficient for the relationship between height and weight is 0.694, okay? Now I will explain this more thoroughly in this part of the handout, okay? Now, when it comes to interpreting the correlation coefficient, okay, again, it's represented by the letter R. The letter R is a value that can range from -1 to +1. That's it, okay? -1 to +1. Now, depending on what that value is, that coefficient tells us about the strength of the relationship between two variables and also about the direction between those two variables, okay? So what we can deduce from the correlation coefficient is that the greater the coefficient, the stronger the relationship is, okay? So a coefficient that is closer to 1, which is the maximum value, we know that that would be a pretty strong relationship, okay? If you were to have a correlation coefficient that is a perfect -1 or a perfect 1, that's indicating a perfect relationship between two variables. Now, let me just say that that is something that we rarely ever see, okay? Also, if you have a correlation coefficient of 0, so if R were to equal 0, that is representing no relationship between those two variables, okay? Again, so the higher the value is, the greater the coefficient is. Now, when we look at this Pearson correlation coefficient between height and weight, it is 0.694. So let's go ahead and round that to 0.7, okay? 0.7, okay? Now, how is that in relation to 1? Well, 7 is pretty close to 1, okay? So we would call this, you know, a pretty strong relationship. It's not super strong. It's not like 0.9 or anything, but it's moderately strong, and it's a positive relationship, okay? Going down here again, it's just a breakdown of what constitutes a positive and negative relationship, which I already discussed. Anytime you have a coefficient with a minus sign in front of it, okay, that means that it's a negative relationship. If it doesn't have that minus sign, then it's a positive relationship, all right? Okay, so let's go ahead and go over some examples of correlation coefficients and their corresponding scatter plots, okay? So here is an example of, here are the examples of perfect relationships, okay, which again, I told you are things that rarely happen, okay, in real life. So here we have a positive one, okay, a +1. So this is indicating a perfect positive relationship, okay? So as one variable goes up, the other one also goes up. A positive relationship is denoted by a line that goes in this direction, okay? It's going to the right, all right? So this is what we see with the height and weight example above, okay? Okay. Now here we have R equals -1. So this is a perfect negative relationship. This is denoted by an increase in a variable is associated with a decrease in a variable, okay? And this is indicated by a slope that goes downward in this way, okay? Now, if we move on to this next part here, these are showing, they're still showing negative relationships, okay? You can see here negative relationship, but these are indicating different strengths, okay? If you have a correlation coefficient of R equals -0.8, so right off the bat, the negative tells us that it's negative, okay? It's a negative relationship, and it's 0.8, okay? So that's pretty close to a 1. That's pretty close to 0.1, which is why this tells us that it's a fairly strong negative relationship, okay? Because 0.8 is close to 0.1, right? Now, when we look at a scatter plot indicating a fairly strong negative relationship, of course, your line is going to be going in this way, okay? Because as this variable increases, this one's going downward, okay? Also, we can tell that it's a pretty strong relationship by how close these dots are clustered, okay? If you look at these up here, these dots are really close to each other because they're a perfect relationship. The more imperfect the relationship gets, the more space you see in between these dots. So here, you can see the dots are a little separated, but they're overall fairly close together, and they're following this general trend of downward, okay? Now, if we look at a less strong negative relationship with a coefficient of -0.6, right? This reflects a moderate negative relationship. So again, we still see this downward trend, and you can see the dots, though, are more scattered. There's more space in between them. That's because the correlation is weaker. It's 0.6, okay, not 0.8 anymore. Okay, so there's more space in between the dots. Now, we can look at the same thing, but for positive relationships, okay? R of positive 0.8 means that it's pretty close to 0.1. So we would call this a fairly strong positive relationship. Again, because it's positive, you're going to see the direction going upward, whereas one variable goes up, the other one also goes up, okay? And you can see the dots are pretty close together. then we look at a moderate positive relationship with a coefficient of 0.6, we can see again the line's going upward, but there's more space in between the dots. If you ever run a correlation between two variables and it spits out a correlation coefficient of 0, that means that there is absolutely no relationship between the two variables. And when we look at this scatter plot, and if we were to draw a line through it, it's kind of just going straight. There's no increase or decrease. Okay, and remember, with a correlation between two variables, there's always an increase in one or a decrease in the other, or two increases, right? This one, they're all kind of flat. Okay, they're all kind of going this way, and there's no increase or decrease between the two variables. So this is why we can tell that this is a correlation with a coefficient of 0, no relationship between the variables. Okay, I'm now going to move on to the SPSS portion of the lecture. So go ahead and take this time to open up SPSS and open up your GSS subset. And be sure to open up your syntax file as well. Okay, so I hope you have your SPSS dataset open and your syntax file open. I want to remind you that as you are updating your syntax file, be sure to save it frequently, okay? You can begin by making a note to yourself that these are notes for week 10, and we are going to cover the lesson of bivariate associations using correlations for continuous variables, okay? Okay, so the code to run a correlation for two variables is as follows. You're going to write the word correlations. Okay, on the next line, don't forget to put the backslash at the beginning. You're going to write variables equals, and on this line, you're going to write the two variables that you want to run the correlation for. Now remember, correlations can only be run for continuous level variables, so make sure that the two variables you're putting in are continuous in nature. So I'm going to go ahead and keep the example that I had up here, okay, the variable TV hours, and then the variable age, okay? Now, make sure to write the rest of the code and be sure to check your spelling, okay? Put a period at the end of the code and make sure that everything sort of highlights the same color as you see here, okay? So when we run this code, we're looking for the relationship between hours of television watched and a person's age. Okay, so let's go ahead and highlight the text and run it. Okay, here is my output window. You're going to get an output that looks like this. It's going to first generate descriptive statistics. Okay, so it's telling you, okay, here's some basic descriptives on the two variables that you're using, hours per day watching television, okay? This tells us the average number of hours, and then the N tells us the total number of respondents who responded to that question. And then we see age of respondent here, it's giving us the average age, and then N is telling us the total number of respondents who answered that question, okay? The next part of the output is the correlation box, okay? Now, you can see that the two variables that we just ran, you can see them here, TV hours and age, and then you also see them up here, TV hours and age. Anytime you run a correlation, it's going to produce this sort of matrix, okay, a matrix. Now, what we want to look at specifically is what's inside that matrix, okay? So we want to look at the relationship between TV hours and age, okay? So that's this coefficient here. You have age here, TV hours here. So the Pearson correlation for that is here. Now you'll notice that if you look at TV hours and TV hours, it gives you a Pearson correlation of 1. The reason why it says 1 is because it's looking at the relationship between the same variables. So of course the relationship between TV hours and TV hours is a perfect relationship because it's the same variable, okay? But what we want to look at is this here, the age variable and the TV hours variable. So this here is our Pearson correlation coefficient, 0.2, okay? This bottom, this next row here is giving us the significance value of 0.000. I'm going to go over this in a separate lesson. We discussed this in class several weeks ago, but this tells you how significant this relationship is, okay? Whether it is statistically significant and produced not by chance, okay? That this relationship is happening not by chance, okay? And again, this N is telling us that those are the number of respondents who responded to both of those variables, okay? Now, this correlation coefficient is 0.2, okay? So this is telling us that, first, it's a positive relationship, right? So as one variable goes up, the other one also goes up. But based on the value, right, remember it's going from -1 to +1, a 0.2 is not that strong. So what we would say is that the relationship between TV hours and age is weakly correlated. It's a pretty weak correlation. It's a positive correlation, but it's a weak correlation, okay? And the way you would interpret this is by saying, as the number of hours you watch, actually, no, you can actually interpret it the other way. As age increases, okay, as age goes up, okay, as you get older, the number of hours of television you watch a day also goes up, okay? Because remember, a positive relationship means one variable goes up, the other one also goes up, okay? So as you get older, as age increases, you watch more television, okay? It is a positive, weak relationship, okay? That is statistically significant based on this p-value, okay?